According to the 2023 National Electrical Code, carbon monoxide detectors are not required to be connected to ground fault circuit interrupters. However, some local codes or regulations may have specific requirements for carbon monoxide detector installation. NFPA 1192, the standard on recreational vehicles, also does not explicitly require carbon monoxide detectors to be connected to GFCIs. However, it does state that carbon monoxide detectors shall not be removed or disconnected. While the code does not explicitly prohibit connecting carbon monoxide detectors to GFCIs, there are some important considerations to keep in mind, specifically safety. If the ground fault circuit interrupter trips, it will also cut power to the carbon monoxide detector, rendering it inoperable. This could pose a safety hazard, as occupants may not be aware that the carbon monoxide detector is not functioning. Ground fault circuit interrupters can sometimes trip inadvertently due to factors such as moisture or faulty wiring. This could lead to false alarms or, more importantly, failure to detect an actual carbon monoxide leak. If the carbon monoxide detector is connected to a ground fault circuit interrupter that protects other appliances or outlets, it may be inconvenient to reset the ground fault circuit interrupter if it trips due to a separate issue. While not required by code, it is generally recommended to connect carbon monoxide detectors to dedicated circuits that are not protected by ground fault circuit interrupters. This ensures that the carbon monoxide detector will remain operational even if other appliances or outlets trip the ground fault circuit interrupter. When considering the placement and wiring of carbon monoxide detectors, it's essential to consult the manufacturer's instructions for specific guidelines. Different types of carbon monoxide detectors exist, and their installation requirements might vary slightly. Firstly, hardwired carbon monoxide detectors typically require a dedicated circuit to ensure a constant power supply. This is the most reliable option, as it prevents the detector from being disabled due to a trip breaker or a faulty ground fault circuit interrupter. Secondly, battery-operated carbon monoxide detectors offer flexibility in placement since they don't rely on a direct electrical connection. However, it's crucial to regularly check and replace the batteries to ensure the detector's functionality. Some battery-operated detectors also have an end-of-life warning, indicating when the entire unit needs replacement. Thirdly, plug-in carbon monoxide detectors are convenient as they can be easily installed into any standard electrical outlet. However, similar to sharing an outlet with a ground fault circuit interrupter, plugging a carbon monoxide detector into a non-dedicated outlet can pose risks. If the outlet loses power due to a trip breaker or a ground fault circuit interrupter activation, the carbon monoxide detector will cease to function. In addition to power supply considerations, the location of carbon monoxide detectors within a building is equally important. Generally, carbon monoxide detectors should be installed on each level of the building, including basements, and outside of sleeping areas. This placement ensures that occupants are alerted to the presence of carbon monoxide regardless of where they are in the building. Avoid placing carbon monoxide detectors in areas with high humidity or near fuel-burning appliances, as these conditions can trigger false alarms or damage the detector. It's also important to follow local building codes and regulations regarding carbon monoxide detector placement, as these codes may specify additional requirements based on the type of building or the presence of fuel-burning appliances. Furthermore, regular maintenance of carbon monoxide detectors is crucial for ensuring their continued functionality. This includes testing the detector regularly, typically monthly, to verify that it's responding to carbon monoxide. Most carbon monoxide detectors have a test button that simulates the presence of carbon monoxide and triggers an alarm. If the detector fails to respond to the test, it should be replaced immediately. Additionally, carbon monoxide detectors have a limited lifespan, typically around 5 to 7 years, after which they should be replaced regardless of their apparent functionality. Over time, the sensor in the detector can degrade, leading to inaccurate readings or failure to detect carbon monoxide. When replacing a carbon monoxide detector, it's essential to choose a model that meets current safety standards and is certified by a reputable testing laboratory. Look for detectors that comply with UL 2034, the standard for single and multiple station carbon monoxide alarms, or other relevant safety standards. This ensures that the detector has been tested and verified to accurately detect carbon monoxide and provide reliable warnings. In summary, while the National Electrical Code does not explicitly prohibit connecting carbon monoxide detectors to ground fault circuit interrupters, it's generally recommended to avoid this practice due to the potential safety risks. Connecting carbon monoxide detectors to dedicated circuits ensures a constant power supply and prevents the detector from being disabled by a tripped ground fault circuit interrupter. Additionally, proper placement, regular maintenance, and timely replacement are crucial for ensuring the continued functionality of carbon monoxide detectors and protecting occupants from the dangers of carbon monoxide poisoning. It's also important to be aware of local codes and regulations regarding carbon monoxide detector installation, as these codes may specify additional requirements based on the type of building or the presence of fuel-burning appliances. By following these guidelines, building owners and occupants can create a safer environment and reduce the risk of carbon monoxide-related incidents. Remember that carbon monoxide is a colorless, odorless, and tasteless gas that can be deadly. Exposure to carbon monoxide can cause a range of symptoms, including headache, dizziness, nausea, and confusion. Prolonged exposure can lead to loss of consciousness and death. Therefore, it's essential to take carbon monoxide safety seriously and ensure that all buildings are equipped with functioning carbon monoxide detectors. Finally, it's worth noting that advancements in technology have led to the development of smart carbon monoxide detectors that offer additional features and benefits. These detectors can connect to a home's Wi-Fi network and send alerts to smartphones or other devices in the event of a carbon monoxide leak. This can be particularly useful for homeowners who are away from home for extended periods or for those who have difficulty hearing traditional alarms. Some smart carbon monoxide detectors also integrate with other smart home devices, such as smart thermostats or smart lighting systems, to automatically shut off fuel-burning appliances or turn on lights in the event of a carbon monoxide leak. These features can provide an extra layer of protection and enhance the overall safety of a home. In addition to carbon monoxide detectors, there are other measures that can be taken to prevent carbon monoxide poisoning. These include ensuring that fuel-burning appliances are properly maintained and inspected regularly, never using portable generators indoors or in enclosed spaces, and keeping vents and chimneys clear of obstructions. By taking a comprehensive approach to carbon monoxide safety, building owners and occupants can significantly reduce the risk of carbon monoxide-related incidents and protect themselves and their families from the dangers of the silent killer. In conclusion, while the National Electrical Code does not mandate that carbon monoxide detectors be on a separate circuit from ground fault circuit interrupters, it is highly advisable to install them on a dedicated circuit. This precaution helps to ensure continuous operation and reliability, safeguarding against the potential hazards of carbon monoxide exposure. Regular testing and maintenance of these detectors are paramount for maintaining their effectiveness. Prioritizing these safety measures significantly enhances the well-being and protection of individuals in residential and commercial settings. It is essential for homeowners, landlords, and building managers to remain vigilant in upholding these standards to prevent carbon monoxide-related incidents and ensure a secure environment for all occupants. Continuous monitoring, timely replacements, and adherence to safety guidelines contribute to a proactive approach in mitigating the risks associated with carbon monoxide, thereby fostering safer living and working spaces for everyone.